Okay, so this is a CHIJ Katong Convent end of year exam 2017 revision assignment 2. Okay, first question, which substance has particles in a disorderly arrangement at room temperature? So room temperature is 30 degrees Celsius, so the keyword is disorderly arrangement. So if you look at A, B, C, D, for A, where is the room temperature? Where is 30 degrees Celsius? So the 30 degrees Celsius is actually above its boiling point. Okay, it is above its boiling point, which means that this substance must be a gas. Alright, so if you look at the other three, 30 degrees Celsius is below its melting point. Okay, so 30 degrees Celsius is here, 30 degrees Celsius is here, 30 degrees Celsius is here, which means that below melting point, then it must be a solid. Alright, so obviously disorderly arrangement, gas, the particles are disorderly arranged. So the answer is A. So number 1 is A. For number 2, diffusion experiment. Which gas when present in the beaker over the porous pot? So basically it's asking you what is the gas here? Okay, will cause the water level at Y to rise. Now at Y there is air pressure, okay, pressing against it. And over here also there is a pressure exerted by the oxygen gas. So the only reason that this water level at Y can rise is because the pressure here is more than the pressure here. Okay, when the pressure here is more than the pressure here, then it will push it down, and then this water level Y will go up. Okay, so this one the pressure is higher. This one, the pressure is lower. Now, the reason that the pressure exerted by the oxygen gas is high is because of the rate of diffusion of the gas inside the porous pot is more than or is faster than the rate of diffusion of the oxygen out of the porous pot. Into the porous pot, faster than out of the porous pot, so there will be a lot of gas, gas particles inside. So when there are a lot of gas particles inside, then the pressure here will be very high and then push it up. Okay, so basically you can say that the rate of diffusion into porous pot, okay, must be faster than the rate of diffusion out of porous pot. So when the rate of diffusion into the porous pot of this gas is faster than out of porous pot, it means that this gas must have a lower molecular weight. The MR must be lower, inside lower, so that it can pass through the porous pot faster. Oxygen must be, the MR must be bigger, so that the rate of diffusion for it out of the porous pot will be slower. So this gas here, the MR must be smaller. Oxygen, the MR must be bigger. So what would be the MR of the oxygen? MR of the oxygen is 16 plus 16, which is 32. Which means that this gas here, the gas that needs to be found, the MR must be less than 32. So we have to find out here what is the MR of the carbon dioxide, which is 12 plus 16 times 2, 44. And then this one is 35.5 times 2, which is 71. You have to refer to the periodic table. And the methane is 12 plus 4, 16. Yeah, so this must be the answer because 16 is less than 32. Let's look at nitrogen. Nitrogen is 14 plus 16 times 2, which is 32, 46. Okay, so the only gas whereby its MR is smaller than 32 is 16, which is CH4. Alright, so it's all about comparing the rate of diffusion of the gases into the porous pot and out of the porous pot. Alright, let's look at this question here. Hydrogen chloride, very soluble. Hydrogen chloride is HCl, very soluble in water. Whereas chlorine, Cl2. Now, chlorine is Cl2, it's not Cl because chlorine is a halogen, an O halogen. Okay, this one is a halogen. And O halogen are diatomic, meaning that they exist as an atoms of two, as a molecule of two atoms. Okay, like Cl2, another halogen would be fluorine, F2, and then bromine, Br2. So this one is slightly soluble in water. This one is very soluble. HCl, very soluble. Chlorine, slightly soluble. So both gases can be dried using concentrated sulfuric acid. So this one is a drying agent. So you can find this in chapter 2. You can so this is actually a chapter 2 question, experimental technique. So you want to obtain pure dry chlorine from damp chlorine containing a small amount of hydrogen chloride. So basically at the end of it, what we want is pure dry chlorine. So let's look at the options one by one. Now you have damp. Damp means wet. Okay, damp Cl2 and HCl. Okay, goes bubble into the concentrated sulfuric acid. So what comes out here? So this one is a drying agent, right? So what comes out here? What comes out here? What is inside this tube here would be dry Cl2, because drying agent ma. So the damp Cl2 will become dry Cl2. How about the HCl? HCl, you get a dry HCl because it's a drying agent. And then after that, it bubbles into water. Whatever that goes into the water will become wet. So what comes out here is wet Cl2. And then how about the HCl? HCl is gone already because it is very soluble in water. So there wouldn't be any HCl coming out from here. So what comes out from here? It's only Cl2. But of course, the Cl2 here and the Cl2 here, this one would be lesser because Cl2 is slightly soluble in water. Okay, this one will be more. This one will be, because some of the Cl2 would have dissolved in the water already. So what comes out here is wet Cl2. But the question wants dry, pure dry Cl2. Now let's look at B. B, you have water. So when it goes into the water, this HCl will dissolve into the water because again it is very soluble in water. So what comes out here, there won't be any more HCl, but there will be wet Cl2. What is inside here would be wet Cl2. Then after that, you bubble into concentrated sulfuric acid. It's a drying agent, right? So what comes out here would be dry Cl2. Okay? Where is the HCl? Dissolve into the water already. So this is exactly what the question wants. I want pure dry chlorine. So this is dry chlorine. Alright? So this question 3. So you have to look at it carefully, one by one. Okay, when it bubble into the water, so you have to look at the solubility of the Cl2 as well as the HCl into the water. HCl very soluble in water, so there will not be any more HCl going into the other delivery tube. Alright. Now let's look at number 4, acid-alkali titration. The acid was ran from the burette into the conical flask. So for titration, you have something like that. Okay, this is burette, right? So burette, okay, must draw this into the conical flask, which is reused for subsequent run. So conical flask. Alright, what is the, so you have acid, and then you have acid was run into the conical flask, which is reused for subsequent runs. So over here must be the alkali. Over here must be the alkali. Acid-base, acid-alkali titration. So what is the best procedure for rinsing the flask? Now before that, this alkali, where do you get it from? This one you must use a pipette. This alkali, usually we use 25 cm cube, right? So you have to use pipette to transfer 25 cm cube of the alkali into the conical flask. Okay, best procedure for rinsing the flask. Now, if you want to rinse this flask, can you rinse with the alkali? If you rinse with the alkali, some alkali will stick to it. And then you use the pipette and transfer 25 cm cube, meaning that at the end of it, there will be more than 25 cm cube of alkali inside the conical flask. So you cannot use alkali to rinse your conical flask. Cannot already. Okay, so these two options are out. How about acid? Now this is acid alkali titration. If you rinse it with acid, what will happen? If you rinse it with acid, then some of the acid would neutralize some of the 25 cm cube alkali here. So which means that at the end of it, the volume of acid that you obtain to reach the end point would be lesser. So you cannot rinse with acid. Okay, therefore you have to rinse with tap water as well as the distilled water. So the answer is B. Okay? Alright? Number 4. So you have to understand what is this titration experiment, how to do it. The apparatus shown is used to distill a dilute solution of ethanol in water. So ethanol, they give you already the boiling point of ethanol as well as water, which is 100 degrees Celsius. So which graph shows the change in concentration of the ethanol in the boiling flask as the distillation proceeds? So what happened is, at first, let's say 78 degrees Celsius, the ethanol will boil, will evaporate, and then we'll be able to pass through the glass beads and then get distilled at the condenser here. Get condensed at the condenser and get collected here. So at 78 degrees Celsius, the ethanol will start to distill. So basically the concentration of the ethanol will decrease until 0. Until there isn't any more ethanol in the round bottom flask. Okay, change of concentration of ethanol in the boiling flask. So it will decrease and then become 0. This one cannot increase and then decrease again. Okay, all this doesn't make sense. So the answer is C. Because ethanol has a lower boiling point, so it would get distilled over first. Okay, nothing much to talk about there. Alright, number 6. Diagram shows the chromatogram obtained by the analysis of a single dye. So this is how is the RF value of the dye calculated. RF value, what is the formula for RF value? Okay, this is separation, chapter 3. So RF value is distance traveled by the dye over distance traveled by solvent. Now this one you have to be very careful. Solvent. This distance is taken from the original dye spot. Okay, so for example over here you have original level of solvent. You don't take this distance. This is a solvent from, right? From here to here. This is not the distance traveled by the solvent. The distance traveled by the solvent must be taken from the original level, from the original spot, original dye spot, which is from here. Okay, so from here to here, because only from here the separation will start. Alright, so from here to here is the distance traveled by the solvent. Then of course distance traveled by the dye would be from here to here. Alright, so it is x plus y would be the denominator and y would be the numerator. So the answer is B. Okay, so take note of this. This distance must be taken from the original dye spot, which is from here, not from here. Because here to here there is no separation. Only from here onwards, the separation will occur. The separation of the dye occurs. Okay, which pair consists of a mixture only? Okay, how about here? Air and water. Is air a mixture? Yes, this is mixture. Water is a compound. How about lime water? Lime water would be your calcium hydroxide. Now, anytime it has a chemical formula, it must be an element or a compound. Okay, just like water, H2O. Air, there is no chemical formula for air, so it's a mixture. There are many gases in the air. So lime water and water, so this is compound. Quicklime, what is the chemical formula for quicklime? Calcium oxide, Chow. Alright, so quicklime is a compound. Lime water is also a compound. Then seawater is a mixture, and air is also a mixture. Alright, so the answer is D. Number 8. Naturally occurring bromine has a relative atomic mass of 80. Consists entirely of two isotopes, relative atomic mass 79 and 81. Which statement about the bromine is correct? Okay, the bromine contains the two isotopes in equal proportions. That means bromine 79 and bromine 81, the percentage abundance is the same. Now, this question, you need to, it is very similar to the chlorine isotope in the syllabus. So this one you can refer to chapter 9, the mole chapter. So the mole chapter basically states that chlorine, there are two isotopes of chlorine, right? Chlorine 35 and chlorine 37. Correct? Chlorine 35, what is the percentage abundance? This one is 75%. This chlorine 37 is 25%. So how do you find out the AR of chlorine? AR of chlorine is actually taking the weighted average of the isotope, okay, of the AR of the isotope. So 75%, 100 times 35 plus 25%, which is 25 over 100 times 37. And then if you work this out, you get 35.5. So similarly for this question, I have chlorine 79. I have bromine 79. Okay, relative atomic mass, two isotope. One is 79, one is 81. So that means bromine 79 and bromine 81. So how do you find the AR of bromine? You can see that the AR of bromine is calculated to be 80. Which means that 80 is right in between 79 and 81. Meaning that these two are equal proportion. This is 50%, this is 50%. If you don't believe me, you can actually work it out. 50% is 50 over 100 times 79 plus 50%, 50 over 100 times 81. If you work it out, the answer would be 80. Okay, so this one, bromine contains the two isotopes in equal proportion. It's A. Equal proportion means 50-50. 50%, 50%. Alright. Number 9. Which statement is correct for the two ions F minus and Na plus? So you find out what is the F. So if you look at the number of electron, fluorine, what is the number of electron? Look up in the periodic table, 9 electron. Then how about F minus? Okay, F to F minus, you must gain 1 electron, so it's 10 electron. How about sodium? Sodium atom, how many electrons? 11 electron. Then sodium ion, Na plus. Na, to become Na plus, you must lose 1 electron, so 10 electron. So therefore, the answer is the two ions contain the same number of electrons, C. Okay? So anytime F minus, for all the ions, right, you look at the atoms first. Then from the atoms to the ions, either gain or lose electron. So from there, you do the necessary adjustment. Okay, number 10. Which statement shows that graphite and diamond are different forms of the element carbon? There are different forms of the element carbon. So both graphite and diamond have giant molecular structures. Now this one, it can means they are completely different compounds. Okay, it doesn't mean that they are the same element. Complete combustion of equal masses of graphite and diamond produces equal masses of carbon dioxide and no other products. So from here, we know that both of these graphite and diamond, they are made of carbon because they produce carbon dioxide only. Okay, when you combust with something, that means that something must combine with oxygen, correct? Then you get carbon dioxide. So where does this carbon come from? This carbon must have come from this. So that means this one is carbon. So which means that your graphite and diamond are basically made of carbon. If you look at others, graphite and diamond have different melting points. I mean, it doesn't mean that they are of the same element carbon, because different elements can also have different melting points. Graphite conduct electricity, whereas diamond does not. So different elements can also have this behavior. Okay, so number 10, the answer is B. Okay, number 11. Which diagram correctly shows the arrangement of ions in solid sodium chloride? So this one is in the Ionic Bonding chapter. This is chapter 6. Ionic Bonding. There is actually a diagram on this. Sodium chloride consists of Na plus and Cl minus. You can see the ratio of sodium ion and chloride ion is 1:1. Meaning that each sodium ion is surrounded by chloride ions, and each chloride ion must be surrounded by sodium ion. So if you look at the first one, this sodium ion, it is not surrounded by chloride ion, it is surrounded by sodium ion itself. How can it be? How about this? Na plus, it is surrounded by chloride ion here, but at this side, it is sodium ion. So a positive ion must be surrounded by negative ions in all directions. Okay, so if you look at this, Na plus, okay, chloride, chloride, chloride. So in all direction, it is chloride ion. How about this sodium ion? Sodium ion is here, chloride ion is here. So this is the answer. Okay, so this one, the ratio is 1:1, meaning that all the sodium ion is surrounded by the chloride ion in all direction, and likewise for the chloride ion is surrounded by sodium ion in all directions. And if you look at the ratio, if you look at the ratio of ions, they must be 1:1. So if you look at this cube here, 1, 2, 3, 4, 4 sodium ion, and chloride ion also 4, so it's 1:1. All right. Number 12. What happens when sodium chloride melts? Okay, so sodium chloride is an ionic compound. This NaCl, ionic compound. So ionic compound, that means all the ions, all right, the positive and the negative ions are held by strong electrostatic attraction forces. So ionic compound. So covalent bonds in a giant lattice are broken. This is not covalent. Covalent is non-metal and non-metal. So this one is non-metal and non-metal. That's covalent. Electrons are released from the atoms. There is no electrons in the ionic compound. Ionic compound consists of ions. Electrostatic forces of attraction between ions are overcome. Yes, this one. How about the molecules? When you see the word molecule, it must be covalent. Like for example, H2O is a molecule. H2O is a covalent compound. Another example, O2. O2, we say oxygen molecule. Why? Because oxygen is a covalent substance. It's not a compound, but it's a covalent substance. Okay, number 13. Which statement about groups in the periodic table is correct? Groups. All groups contains both metals and non-metals. Not like group 1, all metals. Atoms So this one is incorrect because, for example, group 1 basically consists of all metals. All are metals for group 1. How about B? Atoms of elements in the same group have the same number of electrons in total. Now, in the same group, all the elements in the same group, what do they have in common? They have the same number of valence electron. Same number of valence electron, not same number of electrons. Then how about C? In group 1, the reactivity of the elements decreases with increasing proton number. So this C basically means increasing proton number means going down the group. Going down the group. So going down the group, what happened to the reactivity? Group 1, going down the group, lithium, sodium, potassium. The reactivity basically increases. Reactivity increases, not decreases. Then for D, in group 7, the melting point of the elements increases with increasing proton number. Again, increasing proton number means going down the group. Because when you go down the group, the proton number increases. So group 7 you have fluorine, chlorine, bromine, iodine, acetylene. So as you go down the group, what happened to the melting point? Now look at the state of matters. Fluorine. What is the state that fluorine is in at room temperature? This one is a gas. This one is a gas. This one is liquid. This one is solid. Solid. So you have to remember this. Group 7 halogen is gas, gas, liquid, solid, solid. So the melting point basically increases. So the melting point increases. Why? Because the solid melting point is higher than the liquid melting point. Liquid melting point is higher than the gas melting point. So as you go down the group, the melting point actually increases, which is correct. Okay? So this part you must remember. Gas, gas, liquid, solid, solid. Okay, 14. Show structure of covalent compound containing element hydrogen H and the unknown elements X, Y, and Z. To which groups of the periodic table do these elements X, Y, and Z belong to? Now, first of all, you need to know what this all these line represent. Now, one line basically means one covalent bond. Okay, one covalent bond. And one covalent bond basically means one pair of electron. So this one line here means one pair of electron. They share one pair of electron. Okay, they share one pair of electron. Why? Why do they need to share? Because they are short of electron. Short of one electron. So short of one electron means that which group, how many valence electron does it have? If you are short of one electron, that means you should have 7 valence electron, which means that you must be short of one electron. Means that you have 7 valence electron. 7 valence electron means that the element is in group 7. VII is group 7. Okay, so you can actually go from the bottom up. Okay, group 7 elements, they have 7 valence electron, right? 7 valence electron means that it's short of one electron. Short of one electron means that it needs to share one pair of electron. Need to share one pair of electron, meaning that this element should have one covalent bond, meaning that it should have one line around it. So we look at X. X has how many lines? 4 lines, which means that this X this X has 4 covalent bonds, meaning that it shares 4 pairs of electrons, meaning that it is short of 4 electrons, meaning that it has 4 valence electrons, meaning that it must be from group 4. So it's either B or C. Let's look at Why? Why? Two lines. Two lines means two covalent bonds. Means share two pairs of electrons. Means short of two electrons. Means if you are short of two electrons, how many valence electrons do you have? 6 valence electrons. Meaning that it is from group 6. So the answer is C. Vi is 6. If you look at Z, 3 lines means 3 covalent bond, means it has it shares 3 pairs of electrons, short of 3 electrons. So it has how many valence electrons? Short of 3 electrons, it must have 5 valence electrons. So it must be in group 5. Group 5. Okay, so this part, your thought process, very important. So remember, one line means share 1 pair of electron. Okay, number 15. A student adds solid zinc powder to a beaker containing aqueous copper 2 sulfate. Which observation are correct? This one is zinc plus copper 2 sulfate. Then you get copper plus zinc sulfate. This is actually metal displacement reaction. Okay, metal displacement reaction. Because zinc is more reactive than copper, so it displaces copper from copper 2 sulfate to form copper and zinc sulfate. So this one, this copper gets kicked out. So this one is gray color. This one is blue solution. This one is reddish brown. This one, zinc sulfate, is colorless. So you can see color of the solution fades. Blue to colorless, correct? Red-brown deposit is formed at the base of the beaker. Yes, because of the copper. Bubbles of gas are rapidly evolved. There is no gas being evolved here, being released here. So the answer is 1 and 2, B. Okay, for 16.